So today we're going completely in triangle mode, and we're going to talk about some of the amazing things about trig. Is that if you know just two things about this triangle, you can find all the other things. So if you know this angle here and maybe the length of this side, the opposite side, you can find the adjacent side, you can find the hypotenuse. Also, if you just know the opposite and the adjacent side, you can find the hypotenuse with the Pythagorean theorem. I will also write these as A, B, and C, where the A squared plus B squared equals C squared. And once you know these things, you can find the trig functions. You can find this angle here if you work backwards. That's another step for another day. But today we're going to take a look at if we know, say, the sine of this angle. We don't even need to know the angle itself. We just need to know the sine of this angle. Let's say we had a triangle with some angle theta here, and we'll say the sine of theta we knew was 3/5, and that this side here was 9. I'm trying to pick numbers that work nicely. But that side was 9, and this was a right triangle. What are the lengths of these sides? Well, here 9 is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we know that sine equals 3/5. So sine is the ratio of this side, the opposite side, to hypotenuse. And that also equals opposite over hypotenuse. So hypotenuse, so 3/5 equals opposite over hypotenuse. We know the opposite side is 9, so let's multiply. Let's see, we can say multiply both sides by h. We'll get 3/5 h equals the opposite side, or h multiply each side by 5/3 equals 5/3 the opposite side. This is O, not 0. And now we just substitute what we know the opposite side is. That's 9. So this is 5 times 9 over 3, which simplifies to, let's see, 5 times 3 is 15. So we know that the hypotenuse is 15. Okay, so there's a couple ways to find A. We know that A squared plus B squared equals C squared. So we can use that to find A. We also know that sine squared, which is really, the Pythagorean theorem has another format. You can see this is really the same thing. That equals 1. You can use that to figure out what cosine of theta is and then find A. Let's do it both ways and see if they work out. Well, I don't want to be square rooting. Well, we'll give it a try. Just for fun. This is to show you that you can use, all you need is an angle or the value of a sine or cosine of that angle and a length of a side, and you can find the other two sides. Well, let's use sine squared plus cosine squared equals 1. So what is cosine of theta? Let's subtract sine squared and take the square root of both sides. It's going to be 1 minus sine squared theta. See how we just rearranged that equation to get this? Subtract sine of theta from both sides, get cosine squared of theta by itself. and then take the square root of both sides to get rid of the square root side. Alright. So sine squared theta, sine of theta is 3/5, sine squared theta equals 3 squared over 5 squared, 9 over 25. So cosine of theta equals the square root 1 minus 9 over 25. That's 25 over 25 minus 9 over 25, which equals square root 16 over 25. Probably a lot of you see where this is going at 16. Oh, that's nice, it's a perfect square. It's 4. 25, oh, that's nice, that's a perfect square, that's 5. So cosine of theta equals 4 over 5. Okay. So that worked out nicely. And this is, again, the secret of your third favorite triangle is hidden in here. It's actually the 3, 4, 5 triangle. That gives us cosine theta is 4 over 5. We know that cosine of theta equals 4 over 5. We know that also equals adjacent over hypotenuse. And we know that the hypotenuse is 15, so we can find the adjacent side. Adjacent side is 4/5 of the hypotenuse, which equals 4 times 15 over 5. Let's see, 15 over 5 is just 3. That ends up being 12. So this side here is 12. Okay, so this is 3 times 3, this is 3 times 4, this is 3 times 5. This is the 3, 4, 5 triangle, just a little bigger. This is one of the nice triangles. The angle here is not terribly nice. It doesn't work out to be something very nice. I think it's like 35 or 37 degrees. Anyway, but it does work out nicely this way. So if you know the angle, and this doesn't have to be a nice angle, you can find the sine, and then you can find the other sides. One last thing to notice, if these are sort of co-angles, say this angle up here is theta. Suppose we knew that sine of theta equals 3/5. What is cosine of alpha? Alright, sine is opposite over hypotenuse. Cosine is adjacent. For this alpha, this is going to be the adjacent side. The same as the opposite side over hypotenuse. So in this case, if you have co-angles, and the sine and cosines, where these cos come in, but we don't actually do that much with them. Notice that that's going to be the same thing. So the sine, the other function is the same for that angle, for sine and cosine. Okay? So if you're more comfortable with the Pythagorean theorem, you can use that to solve a lot of things. Once you get two sides, you can get the third one that way. Or you can use the Pythagorean theorem sort of rewritten like this. Let me show you one last time how that's done. So in this terminology, Pythagorean theorem is opposite side squared plus adjacent side squared equals the hypotenuse squared, right? A squared plus b squared equals c squared, except we're calling these O, A, and H. What if we divide everything by h squared? We do it to both sides, so it doesn't change anything. We have O squared over h squared plus a squared over h squared equals h squared over h squared. O squared over a squared is sine squared theta. Oh, it's just so pretty, I like to do it to show you again. It's nice to see that these things work out. Hypotenuse squared over hypotenuse squared is going to be 1. So there is sort of the, I don't know, you call it a Pythagorean identity of sines, the sine flavor of the Pythagorean theorem. Same thing. So now you should be able to solve any problems where I give you an angle and a side and ask for the lengths of the other sides. Maybe I give you 2 sides and ask for the third side. Or maybe I give you a side and then ask for what the sine of that angle is. Okay? Good.